to True Projects. In this video, we are going to explain about the project that is Network Intrusion Detection Method based on CNN BiLSTM attention model. Before getting into the execution, first let us understand what is the project about. So, when we talk about attacks in cybersecurity, we are essentially referring to malicious actions that target vulnerabilities in the system, networks, or devices to cause harm. These attacks can have range of outcomes like stealing the sensitive data, crashing systems, or disrupting services. One such attack that has been causing a lot of concerns recently is botnet attacks. These botnet attacks are like a group of compromised devices that are controlled remotely by a hacker. These devices could be anything from your personal computer to smart devices in your home. Once these devices are infected with the malware, the hacker can use them to perform attacks, usually without the owners even knowing that their devices are being used. These botnets can be used for the things like DDoS attacks, that is distributed denial of service attacks, which where the devices flood a system with so much traffic that it crashes, or they can be used to steal the personal information, install more malware, or even control their other devices. What makes botnet attacks so tricky is how adaptive they are. As malware keeps evolving, traditional security methods that used to work just fine are now struggling. To keep up, the systems that are still in place often throw out too many false alarms, or worse, miss the actual attack. That means the bad guys are slipping through the cracks and still causing the damage. And as more and more devices getting connected to the internet, the problem just keeps get bigger. That's why we need new improved methods that can keep up with the fast evolving nature of these attacks. And even more, the botnet attacks are becoming increasingly sophisticated with the attackers using advanced techniques to evade detection. Traditional methods for identifying these threats often struggle to keep up due to the evolving nature of malware and the dynamic behavior of botnets. These outdated detection systems may fail to accurately analyze network traffic patterns, leading to higher false positives or missed threats. As botnets grow in complexity, it is clear that more advanced solutions are needed to effectively protect against these attacks. And this project goal is to create a more robust system that can handle adaptive and evasive nature of botnet attacks, making it more reliable in mitigating the risks associated with these threats. So this project is designed to improve how we detect network intrusions. So it combines three powerful techniques, that is CNN, BiLSTM, and attention mechanism. So first, CNN, that is convolutional neural network, is incorporated to look at the data and extract patterns that point to possible attacks. So think of CNN like a detective that is good at spotting clues or trends in the data, helping to identify what is unusual or potentially harmful. Next, BiLSTM, that is bidirectional long short-term memory. It comes into the play, which is great for understanding how attacks evolve over time. This helps the system not just look at a snapshot of the data, but to understand the sequence of events that lead to an attack. So this is key because many network intrusions happen slowly over time and it need a model that can track those patterns. Then comes attention mechanism. So your attention mechanism, it is like a spotlight that helps the system focus on most important data when making decisions. It makes sure that the system doesn't just look at everything equally but gives more importance to the parts of the data that truly matters in detecting an attack. One of the challenges when it comes to detecting network intrusions is that some type of attacks are much rarer than the other types of attacks, other data, which creates an issue called class imbalance. For example, there might be tons of regular traffic or common attack patterns, but only few examples or more advanced or less frequent attacks. So this imbalance can lead to the model ignoring those rare attacks because the system is more focused on the majority class. So to solve this, the proposed system uses something called equalization loss V2. So this equalization loss V2 acts like special focus on underrepresented data. By doing this, the system gives more importance to those majority class, ensuring that they get the attention they need during training. As a result, the model becomes better at detecting these less common attacks that are often more dangerous. And to make sure that this approach works well, the model was tested on multiple datasets, that is NSLKDD, UNSW NV15, and CIC DDoS 2019, which is commonly used for intrusion detection tasks. And this proposed model is evaluated using accuracy, precision, recall, and FN score, which are the evaluation metrics used to evaluate the model. And to further improve the performance, here we have incorporated voting classifier, which is an ensemble method which will combine the predictions of multiple individual models. So think of it like getting opinions from different experts and then making a decision based on the majority vote. By doing this, the system becomes more accurate because it draws on the strengths of different models, which helps to reduce the chances of making mistakes in the predictions. And here we have added front-end using Flask framework. This makes the intrusion detection system more user-friendly. Instead of just running behind the scenes, user can now easily interact with it through a simple interface. They can test out the system, check that how it performs, and we have made sure that user authentication, we have included user authentication for this. So this ensures that only authorized users can access the system. So here we have added the user authentication mechanism too, through which the interface is secure and users can access the system securely. And to implement this project, we have followed the steps mentioned in the flow of work. So first, what we have done is we have imported all the necessary libraries and packages required for data processing, model building, evaluation, and front-end development. Then comes exploratory data analysis, where we have imported the three datasets. That means we have loaded three datasets: NSLKDD, UNSW, NB15, and CIC DDoS 2019 dataset, which serves as the basis for intrusion detection. And this step helps us to understand the features and structures of the data. Then we remove duplicate data, that is duplicate entries, to ensure that data integrity. Then comes drop cleaning. So any irrelevant or missing data is dropped to improve the quality of the dataset. Then comes data visualization. So visualizing the data helps to identify patterns and relationship between features, which aids in understanding the dataset better and making informed decisions during the model building. Then comes label encoder. So the categorical labels in the dataset are converted into numerical values using label encoding, making it easier for machine learning models to process the data. Then comes feature selection using select percentile. So here we apply feature selection techniques such as select percentile to choose the most important features that contribute to the detection of intrusions. Then we split the data into train and test sets, where training set is used to train the model and test set, that is validation set, is used to evaluate the model performance. And then we initiate, that means we construct all the models that we are building in this project, and then the constructed model, that is the initiated model, is used to train the data. So here, the model learns the patterns associated with the intrusions and normal network traffic. Then we evaluate all of them using accuracy, precision, recall, and FN score, and they are compared through the graphs. Coming to the part of front end, so front end interface is developed using the Flask framework, which allows users to interact with the model. A registration and login system is integrated with using SQLite for secure access. And in the front end, users will be able to provide input feature values for the attack detection purpose that will be pre-processed at the backend. It will be fed to the train model, and train model will be giving us the prediction, predicting the attack. So this is how we have implemented the project. And moving on to the algorithms used, these are the algorithms trained on all the three data sets to predict the attacks. So here we have used DNN, CNN, CNN with LSTM, CNN with BiLSTM, CNN with attention, CNN with GRU attention model, random forest, ADA boost, KNN decision tree, and voting classifier, which is the extension model. And to implement, we need basic requirements, which are hardware and software. Coming to hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. And coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let's execute. So open the code folder which contains source code files. These are the source code files in the code folder of the project. Let us understand each of them. How will they be used in this project? So here in this folder, we have the dataset that is used in the project. So these are the files of CIC DDoS 2019 dataset. These will be loaded into the code, Python notebook, and then they will be processed there. And here in the NSLKDD folder, we have NSLKDD dataset that we have used in this project. And in this UNSW NB15 folder, we have the UNSW NB15 dataset. And here in the static folder, we have CSS, JavaScript, and Bootstrap files, which are important for the visual appeal. And in this templates folder, this folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And in this app.py file, this .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And here we have notebook files, model files. So these are the model files which contain the algorithm information and that will be loaded into the project code during runtime of the application. And here we have three notebook files. So these are the three Jupyter notebook files which contain the combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And these are the backend codes. So here in this folder, that is CIC DDoS 2019 Jupyter source file, we will be loading this dataset and we will be training all the models on the dataset for detecting the attacks. Similarly, KDD Cup and UNSW NB15. And in all these files, we have the samples. I mean, in all these sample files, we have the test cases that we will be using in the front end for detecting the attacks. And this is the signup.db file. This file is a database file which is used to store the user information. So this is all about the code folder. Now let's execute. So copy the path of the code folder from the address bar of the file explorer. I'm copying it. Now open Anaconda prompt. It is open. Give the command cd, give the space and paste the copied path. Now click on enter. So current directory is changed to the code folders path. Now compile app.py file. So give the command python space app.py and now click on enter. So this command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port, unless configured differently. So this is the local host and this is the port. Now we have to copy this local link provided by the Flask framework and paste it in any web browser. I'm copying the link. So we need to paste this link in the browser. I prefer Chrome, so I'll paste it in that. Paste the link here, click on enter. So this is the web page of the project which is displayed in the browser. This is developed using Flask framework. Now we need to get signed up first. So click on sign up and enter all the registration details if you are registering newly. I have already registered, so I'll directly sign in. Click on sign in. Give your username and the password. Click on login. We have logged in successfully and we are redirected to prediction page of the project. So here we are doing prediction for all the three data sets. Let's do prediction first for the KDD cup. So click on that. So these are the inputs to be given for predicting the attack. Let's understand each of them. So the first one we have is the flag. It indicates connection status such as successful or failed, helping to classify the connection type. Then we have source bytes. So these are the number of bytes sent from the source to the destination reflecting the data transfer value. Then we have DST bytes. So these are the number of bytes sent from the destination to the source indicating return data flow. Then we have count. It is the total connections made by source to destination, potentially signaling abnormal activities like DDoS. Then we have error rate. It is the percentage of failed connection attempts from the source highlighting potential issues or attacks. Then we have same error rate, that is same SRV rate. It is the percentage of connections made by the source to same service indicating repetitive behavior. Then we have different SRV rate. It is the percentage of connections to different services showing diverse connection behavior. Then we have destination host SRV count. It is the number of connections from the destination to multiple services indicating service interaction. Then we have destination host same SRV rate. So it is the rate of connections from the destination to the same service pointing out possible abnormal patterns. Then we have destination host different SRV rate. It is the rate of connections to different services which could highlight unusual probing behavior. Then we have destination host error rate. So it is the error rate for destination connections indicating failed or malicious attempts. The last one we have is destination host SRV error rate. It is the error rate for service level connections at the destination, helping detect blocked or failed service request. So this is all about the parameters. Now let's enter them. So let's open the sample file of NSL KDD dataset. So in this we have samples of NSL KDD dataset. So let's track this. And here in the last column, we have a tag. So let's apply filter to it and see how many classes we are supposed to predict. So here we are supposed to predict 5 classes. Let's apply filter class 0. So I have applied filter to class 0. Now let's enter the values where flag value is 5, SRC bytes are 0, destination bytes are 0, count is 128, and error rate is 1. Same SRV rate is 0.04 and different SRV rate is 0.07. 5 is the destination host SRV count, and 0.02 is destination host same SRV rate, and 0.06 is destination host different SRV rate. And the next one we have as 1 and 1. That is last two values are 1 and 1. Now click on predict. So this given information, it will be processed at the backend, and then trained model will be giving us a prediction. So here we got the prediction that attack is detected, and that attack type is DOS attack. So here DOS attack has been detected. Now let's apply filter to class 1. So here class 0 refers to DOS 1, I mean DOS attack. Let's apply filter to class 1. Let's enter the values. So here click on prediction, KD cup. Let's enter the values where flag value is 9, SRC bytes are 8, next value is 0, 1, 0, 1, 0, 86, 1, 0, and we have zeros next to values also. Now click on predict. So here we got the prediction that attack is detected, and that attack type is prob attack. So here prob attack has been detected where class 1 refers to the prob attack. Now let's apply filter to class 2. Click on OK. And now we are supposed to enter this value. So let's enter this case. Click on prediction, click on KDD cup. So here flag value is 9. Source bytes are 334. Destination bytes are 0. Count is 2. 0 is the error rate. And 1 is same SRV. And 0 is the different SRV. 11 is the destination host SRV. And 1 is destination host same SRV. Then we have 0 that is different destination host different SRV. Then we have zeros and next values also. Now click on predict. So here we got the prediction that attack is detected, that is R12 attack. So here R12 attack has been detected. Now let's check with class 3. So apply filter to class 3. Click on OK. And now click on prediction KDD cup. So let's check with this case where flag is 9, 0, 5020, 3, 0, 1, 0, 83, 1, 0, and all the values are 0. Now click on predict. So here we got the prediction that attack is detected, and that is U2R attack. So here class 3 refers to U2R attack. Now let's check with the last class, that is class 4. So these are the values that we're supposed to give as input. Now click on prediction, click on KDD cup. So here flag value is 9. SRC bytes are 202. Destination bytes are 5197. Count is 1, 0, 1, 0, 255, 1, 0. And the next values are also 0. Now click on predict. So here we got the prediction that there is no attack detected. It is normal. So class 4 refers to no attack. We have completed with the KDD cup. Now let's check with the UNSWNB. So click on that. So these are the parameters to be given. Let's understand each of them. The first one we have is a duration. So here, duration is the total duration of the connection, which can indicate the normal or suspicious behavior of a connection based on its length. Then we have S bytes, that are source bytes. It is the number of bytes sent from the source to the destination, reflecting the data transferred in the communication. Then we have DB bytes, that is destination bytes. It is the number of bytes sent from the destination to the source, helping to measure the response data flow. Then we have rate. It is the rate of data transfer during the connection, slowing, that is showing the speed and volume of the data being sent. Then we have S load, that is source load. It is the current load on the source, which might show unusual behavior if the source is overloaded or under attack. Then we have deload, that is destination load. It is a load on the destination system indicating whether the system is receiving an unusual amount of data. Then we have DIN packet, that is the destination input packets. So these are the number of packets received by the destination indicating the volume of communication. Then we have S mean, that is the source mean. It is the average number of packets sent by the source, helping to identify whether the source is behaving normally or anonymously. Then we have D mean, that is destination mean. It is the average number of packets received by the destination, providing insights into typical communication patterns. Then we have CT state TTL, that is the connection time to live. It is a measure of time a connection remains active before terminated, which can indicate timeout or attack attempts. Then we have CT DST Sport LTM, that is destination sport lifetime. It is the time a destination port remains active for connections, helping to identify persistent connections or abnormal service usage. The last one you have is CT SRV DST, that is connection time to service on the destination. So these are the number of times that the destination has communicated with the services, useful for detecting unusual patterns or multi-service interactions. So this is all about the parameters of UNSW dataset. So now let's give the test cases which are in the sample folder. So open the UNSW, open this project application. So let's apply filter to class 2. So select class 2 and click on OK. So these are the test cases. Now let's try with this case where the duration is 1.1e hyphen 05 and the source bytes are 200, destination bytes are 0, rate is 1 lakh, and then S load value is 80 lakhs. So let's copy and paste it, and then D load is 0, DIN packet is 0, 100 is S mean, D min is 0, CT settle state TTL is 2, 4, and 10. Now click on predict. So just wait for a while. It is being processed at the backend. And here we got the prediction. So we got the prediction that there is attack detected and that attack type is analysis attack. So here analysis attack has been detected. Now let's try with class 3. So apply filter to class 3. Click on OK. And now click on prediction of UNSW. So now let's try with this case. So copy the duration, that is 0.18, and then source bytes are 1460, destination bytes are 268, rate is 78.94, S load is 55326, that is 55,326. Sorry, we have copied it wrongly. So copy the rate, paste it here, and then copy the S load value, D load, then packet, S mean, that is 146, and then we have D mean as 45, 1, 1, 1. Now click on predict. So here we got the prediction that attack is detected and it is exploits attack. So here you can observe that exploits attack has been detected. Now let's check with class 4. So apply filter to class 4. So now let's enter this case. Click on prediction under UNSW. I have entered all the values. Now click on predict. Here we got the prediction that there is an attack and that attack type is fuzzers attack. So here fuzzers attack has been detected. Now let's check with the class 5. So apply filter to class 5 and click on prediction, click on UNSW. So let's try with this case. So on the duration give 7E06, S bytes are 114, D bytes are 0, and then rate is 142857.14, and then S load is 651428560 057 0, and then here we have 2, 4, and 4. Now click on predict. So here we got the prediction that attack is detected and that attack is generic attack. You can observe, right? Generic attack has been detected. Now let's check with the class 6. So apply filter to class 6. Click on prediction, click on UNSW. So let's enter the values. Let's try with this case. Here I have entered all the parameters. Now let's click on predict. And here we got the prediction that attack, there is no attack detected. It is normal. So here attack, there is no attack with the class 0. So here it is normal. Now let's check with the class 7. So apply filter to class 7. Click on OK. Now let's check with this case. So click on prediction and click on UNSW. So the duration is 1E, 1E hyphen 05. S bytes are 168, 0, and the next value is 1 lakh. Then we have 6 lakhs 72,000, I mean 6 crore 72,000 it is. And then we have deload, that is 0. We have next two values as 0. So give it as 0, 0, 84, 0, 2, 1, and 1. Now click on predict. So here we got the prediction that attack is detected and it is reconnaissance attack. So here you can observe that reconnaissance attack has been detected. In similar way, you can check with all the cases. It will work with all the cases. Now let's do the prediction for the last data set. So click on CIC DDoS 2019. So here we have some parameters that are need to be entered. So let's understand what are these parameters are. So here the first parameter we have is the flow duration. It is the total time duration of the flow, that is connection from start to end, indicating how long the communication lasts. Then we have forward packets length total. It is the total number of bytes in the packet sent from source to the destination in the flow, showing the volume of the data transmitted in the forward direction. Then we have forward packet length max. It is the size in bytes of the largest packet sent from the source to the destination, helping identify unusually large data transmissions. Then we have forward packet length min. It is the size in bytes of the smallest packet sent from source to the destination, which may be useful for identifying small fragment packets. Then we have forward packet length mean. It is the average packet size of packets sent from the source to the destination, providing insight into the overall data flow in the forward direction. Then we have flow bytes. So it is a rate at which bytes are transferred during the flow, indicating the rate transfer speed throughout the connection. Then we have flow packets. It is the number of packets sent per second during the flow, helping to measure the intensity of communication. Then we have flow IET mean. It is a mean enter arrival time of packets in the flow, showing the average time between consecutive packets. A sudden increase may indicate delays or network issues. Then we have flow IIT max. It is the maximum inter-arrival time between any two packets in the flow, helping to identify periods of inactivity or delays. Then we have forward packets. It is the number of packets sent per second in the forward direction, providing insights into the communication rate from source to destination. Then we have packet length min. It is the size, that is in bytes, of the smallest packet in the flow, which could indicate small data transfers or fragmented packets. Then we have packet length max. So it is the size of the largest packet in the flow, helping to identify potential anomalies related to unusually large packets. Then we have packet length mean. So it is the average size of packets in the flow, which helps in identifying typical packet sizes for the network traffic. Then we have average packet size. It is the average size in bytes of all packets in the flow, helping to determine whether the packets are unusually large or small. Then we have average forward segment size. It is the average size of the segment sent in the forward direction, providing insights into how much data is being transferred in each segment. The last parameter we have is the subflow forward bytes. It is the number of bytes sent in the forward direction within a subflow, helping to monitor the volume of the data transferred in small chunks of the communication. So this is all about the parameters. Now let's enter them. So open the sample file of that data, that is sample DDoS. So these are the parameters that we are supposed to give as input. So let's apply filter to target class. So apply filter. So here we have total 8 classes. Let's apply filter to class 0 and check with this case. So flow duration is 20765. 82 is the forward packet length total, 41 is the forward packet length max, and then forward packet length min is also 41 and mean is also 41. And then we have flow bytes. So copy the flow bytes and paste it. And then flow packets, that is 192.631. And then we have flow IET max, sorry, flow IET mean it is. And then we have flow IET max, that is 20761. And then we have forward packet length min, it is 41. And then we have 57, 57 packet length mean is 47.4, 59.25, 41, 82. Now click on predict. So here also the given input, it will be pre-processed at the backend and then train model will be giving us the detection. So here we got the detection that there is no attack detected. It is benign case. So here there is no attack. Now let's check with the class 1. So apply filter to class 1. You're supposed to enter these values. So click on prediction, click on CIC DDoS 2019. Flow duration 2. Then forward packet length total is 29441472. And it is same for next two values too. Then we have flow bytes, that is 1.472E plus 09. And then we have flow packets, that is 10 lakhs. And then we have 2 as flow IET mean. The next value is also 2. And then we have forward packets that are also 10 lakhs. So paste it here. Then we have packet length mean 1472. Length max is also same. Length mean is also same. And then we have average packet size, that is 2208, 1472 and 2944. Now click on predict. So here we got the prediction that there is attack detected and that attack type is LDAP attack. You can observe, right? LDAP attack has been detected. Now let's check with the class 2. Apply filter to class 2. So we are supposed to enter these values. Click on prediction. Click on CIC DDoS 2019. I have entered all the parameters here. You can observe. So now click on predict. So here we got the prediction that attack is detected and that attack is MSSQL attack. So it is MSSQL attack. Let's apply filter to class 3. Click on OK. And now click on prediction. Click on CIC DDoS 2019. So let's try with the first case where the flow duration is 46, 530, 265, 265 and 265. And the next value, that is flow bytes. So copy the value and paste it. And the next value is flow packets, that is 43478. And then we have 46, that is flow IIT mean and max are 46. Both of them are 46. And then here we have forward packet, that is 43478.26 and 265, 265, 265, 397.5, then 265, 530. Now click on predict. So here we got the prediction that there is an attack and that attack type is net BIOS attack. So here net BIOS attack has been detected. Here class C refers to net BIOS attack. Now let's apply filter to class 4 and enter the values. Click on prediction, click on CIC DDoS 2019. So I have entered all the parameters here. Now click on predict. So here we got the prediction that attack is detected and that attack type is port map attack. So here port map attack has been detected. Now let's apply filter to class 5. Click on OK. So let's enter the parameters. Click on prediction, click on CIC DDoS 2019. So I have entered all the values here. Now let's click on predict and see what will be predicted. Here we got the prediction, and that is attack is detected, and that attack type is SYN attack. So your SYN attack has been detected. So your class refers to SYN attack. Now let's apply filter to class 6. So these are the values that are to be entered. So these are different test cases. Now let's enter the values. So let's try with this case. So I have entered all the cases. Now let's click on predict. And here we got the prediction that there is attack detected and that attack type is UDP attack. So here you can observe that UDP attack has been detected. So in this way, class 7 will also work. So you can try with that. Now let's check with the graphs. So click on graph. Let's see the graphs of KDD cup. So here the first graph which we have is the sample outcome graph. Here on x-axis we have all the attacks that we are predicting in this project. So here we call it as target class, and on y-axis we have count of each target, that is each class. And this is the correlation matrix graph. This shows the correlation between variables. And here we have accuracy comparison graph. Here on x-axis we have accuracy score, and on y-axis we have all the algorithms that are trained for detecting the attacks. And here we have precision score. Here we have recall score, FN score. Yeah. So these are the graphs of KDD Cup dataset. And let's see the graphs of UNSW. This is the sample outcome graph of UNSW, and here we have correlation matrix, accuracy, precision, recall, and FN score. Now let's see the graphs of CIC DDoS 2019. So here we have sample outcome graph. This is the correlation matrix, accuracy, precision, recall, and FN score. Now click on sign out. In this way, just by giving inputs to the application, based on the given input, the application will predict whether there is an attack or not. If there is attack, it will detect which type of attack it is. If there is no attack, it will show that there is no attack. It is benign case. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.